Hi, welcome to Carnival. In this episode of Daily Dose, we'll be solving the question named Jumpy Ball. So, in this question, we have a ball and we are throwing it off the ground. Obviously, the ball would go, reach till height h, and then it would come down again due to gravity. And then, since we have a ground here, it would bounce off and then it will move again, traveling upwards. The condition that is given to us is, after each and every fall or iteration, the height of the ball reduces to half of what it was in the previous iteration. So if the ball started off at a height h, that is, it is thrown to a height h, then after coming down and hitting the ground, it will move to a height of half of 10, which is 5 centimeters, right? So and then in the next iteration, it will move to not 2.5, it will move till 2 centimeters. So it is moving on till the floor value of 5 by 2. That is, if we get 2.5, it is rounded off, or it is floored to the value that is below or the lowest integer, right? So that is in this case 2, and hence 5 divided by 2 is given to us as 2. And similarly, the ball keeps on jumping till it reaches a point where it cannot jump. Okay, so the point is we have to find the total number of distance the ball has traveled going from the ground all the way till a height h, coming down and again jumping. Okay, so we have to find the total amount of distance that it has traveled. And what is the logic that we are going to use? Obviously, since we are given the height h, we'll have a distance variable, and then it would just iterate through all these iterations and count the values of the distance that it has traveled. Okay, so we are going to use a while loop for that, and the while loop's condition is obviously going to be that the height h should be greater than 0. So if it is equal to 0, it means the ball has reached the ground, that is, it is not jumping anymore, and hence we cannot count the value of distance anymore, right? So till we reach the value that is n is equal to 0, the height is equal to 0, we are performing this process of adding the value of distance that is covered by the ball to the variable that we created. Okay, and as I said, after each iteration, the value of n, that is the height, would become half of it. So n would become n by 2. Okay, so these are the two things that we are going to do inside this while loop. Now let's go on to GFG practice and code this logic. So here we are in GFG practice, we have the function jumpy ball. So in this function, we are given the long n as input. So this is not going to be a normal integer, it is going to be a really big number, and hence we have used our data type long, and our output should also be long. Hence, what is our output? The output is the distance. So we are declaring the distance in the variable of long. Okay, and we are assigning it to a value 0. We'll change this value from 0 to another value. We'll see why and what value is that in just a minute. Okay, so the value of long distance is set to 0. So we have declared the value, that is we have declared the variable distance. Now let's move on to the while loop part. While, as I said, the condition is n greater than 0. If it is equal to 0, it means the ball is not jumping anymore. Our question itself is jumpy ball, and if the ball is not jumping, then why count the distance at all? So hence, if the value of n, that is the height, is greater than 0, we'll execute the statements inside this while loop, or else we'll just skip this part and move on to the next part. So if the value of n is greater than 0, in that case we have to perform two things. As I said, after each iteration, the value of n should be divided by 2. That is, of course, one statement. The other statement would be to update the value of distance covered by the ball. So the distance covered by the ball would be equal to, so distance plus equal to, so the existing value of distance is being added on to the new value that we find in this iteration. So what is the value that we are adding? We are adding the floor of n by 2. As I said, we are not just adding floor of n by 2, we are adding the floor of n by 2, because if the height is 5, the ball would jump till n by 2, and 5 by 2 is 2.5. Since we are including just integers here, it is decreased or floored to 2. Okay, and that is why we are using the floor variable. But this is not the end. We have to include the distance that is taken while going up as well as down, and hence the floor of n by 2 just gives us the distance that is traveled while going up. but it does not include the distance that the ball travels while coming down, and hence we have to multiply 2 by this value. So 2 into the floor of n by 2 would give us the distance that is traveled by the ball in that station when it goes up and it comes down. But this floor of n by 2 starts with, oh, I've given the semicolon here, okay. So this floor of n by 2 starts with the second iteration, that is, when we have the initial value of n to be as 10, it is starting from 5. Because as you can see here, 10 by 2 is the first value, that is 5 is the first value that is being added to distance, right, and not 10 itself. But we have to add the initial distance that is being traveled by the ball as well. That is, when we throw this ball upwards, it travels n distance that is given to us as input, and it comes down n distance again, and then it moves on till n by 2, right. So that n plus n, 2n distance is not added to this variable distance using this for loop or while loop, sorry. So what we are doing here, since the while loop does not account to that, we are just adding it initially. This is what I said when I initially said that this is not 0 and we have to change it to some other value. Okay, we are changing it to 2n because the first initial throw that we give to this ball is not being counted by this while loop, and hence we are hard coding it to the distance variable. Okay, now after this while loop, the only thing that is remaining for us to do is to return this distance. So return distance. So the variable long data type is being returned, and it will be printed by the main function, of course. So our job now is to submit this program and verify the output. We have got the output as problem solved successfully, and that is the end of this question. Now let's move on to the try relaxation. If we throw this ball to a height, let us say 5 centimeters, what would be the output? Let me know your answers in the comment section below. If you like this video, please drop a like and comment down below if you have any questions. And please don't forget to click the subscribe button. We'll see you in the next episode of Daily Dose tomorrow. Until then, bye bye.